further east, it is a whole different world. Santa Maria. This island is less rugged, with wide plains and gentle elevations. As different as these islands are, the stones here bear witness to a common origin.
This is a piece of basaltic lava, and you find pieces like this all over the Azores Islands because they're all volcanoes. But they look really different. The reason for those differences have to do with different ages, and age is really important in the Atlantic. Let's look at that in a bit more detail. This is the present-day Atlantic seafloor. Now, let's turn the clock back 240 million years. Europe and America are part of a supercontinent that we call Pangaea. If we let time run forward a little bit, we get to 220 million years. And the first little bit of water appears in the middle of that supercontinent. It's the birth of the Atlantic. And from that time on, the Atlantic is going to grow. Europe and America progressively move apart from one another. At 8 million years, a tiny little point appears in the middle of the Atlantic. That's Santa Maria. The other Azores islands appear one after the other, and at 300,000 years ago, Pico pops its head out of the water. And that's the reason why they look so different. There are 7 million years between those two islands. Every bit of the Atlantic seafloor has its own specific age. In the meantime, there are 5,000 kilometers between America and Europe, or, as the geologists would say, over 200 million years of Earth's history.
Like the entire Atlantic, the Azores were formed on the mid-Atlantic ridge. The young island of Pico, as well as the oldest island in the Azores, Santa Maria, whose mountains have already been worn down by millions of years of erosion. What all the islands have in common is that they are home to a unique, sensitive environment. Far away from the big continents, something special has developed here.